Okay, this is video number 6, periodic trends. We're going to be talking about atomic radius and ionization energy. Hopefully this is the last one and we'll be good to go. All right, so if you'll notice on here, now that we're talking about your two radii, okay, most important thing to understand is this. When you're talking about a radius, you have two different kinds. You have the atomic radius and you have the ionic radius. One deals with only when it's an ion, okay, the radius of an ion, and then the other deals with the distance from, literally, for the most part, to make it easier, the distance from the nucleus to its furthest most outer electron, the valence electron. So, notice that both do the exact same thing though. The trends both go, generally speaking, with the exception of here, and we'll explain this later, they go as you move from right to left and top to bottom, so exactly the opposite of the other two, they actually increase. So on here, in this case, francium is the largest on both. So again, there's our marker element, francium. Okay, so I'm going to move this away and I'm going to try to explain it a little bit. So if you were to look at the periodic table, and again, you guys know I can't draw, so just go along with this. Okay, here's an example of part of the periodic table. Periods 1 through 4 and moving over. Okay, so going from period 1 to period 4, this is the easiest thing to explain. As you go from 1 to 2 to 3 to 4, you all know that you're adding energy levels or shells as you go from one energy level down to the fourth one. And all the way down to the seventh one, you'd obviously have 7 shells. So what I'm trying to say is this. For example, let's look at lithium and potassium. Right now, just from what I've said, you all know that lithium is going to have a smaller atomic radius than potassium, because lithium only have 2 shells, potassium is going to have 4. But let's see it in visual. So if I show you in visual, okay, here it is. There's lithium and there's potassium. Lithium only has 3 electrons, potassium has 19. And here's lithium with 3 electrons, 2 in the first, 1 in the last. Here's potassium. It has 4 shells, 1, 2, 3, 4, and you have 2 in the first, 8, 8, and 1. All right, so now because of that, now you're experiencing the difference in visual time, which is really nice to see. Going from 2 to 4, clearly as you go down the group, 1 shell to 4 shells to 7 shells on the periodic table. You're getting bigger, which is why francium at the bottom here is clearly going to be the largest on the periodic table as in terms of radius. Okay, as you go down, it gets larger. Now, the one that doesn't make sense though is as you go across, it actually gets smaller. So why is that? Well, here it is. As you go across the periodic table, so for example, to go from potassium all the way over to krypton, okay, from potassium, the 4th row, all the way over to krypton, number 36, it gets smaller, or you get larger as you go from right to left. Here's why. Yes, your mass gets bigger. Of course, you're going from potassium, which has a mass of roughly 40, all the way over to krypton, which has a mass of roughly 85. And in addition, you're going from 19 electrons to 36 electrons. So you would say, yeah, of course it gets bigger. Not really. Not in terms of radius. In terms of radius, it actually gets smaller as the mass gets bigger. Okay, so in inverse proportion. Thank you, math teachers. All right, so if you look at this, here's why. Notice how potassium has 19 electrons. I put them in there. Okay, here's kryptons with 36. Okay, so you still have the normal gist. You have the 2, the 8, and the 8, but instead of having only 1 in its outer shell, it actually has so many more. Okay, and because of all of these electrons and the protons in the center, you all know what happens to things that are positive and negative. They attract. And because they're attracting, all of that force actually causes the atom to get smaller and smaller and smaller in terms of radius. So the radius is getting smaller because it's getting pulled toward the center of the nucleus. Or sorry, toward the nucleus. Okay, whereas over here, there's plenty of room. Notice there's not a lot of pull towards the center of the nucleus. Over here, all of this is getting pulled, so that atom actually gets smaller in terms of radius. So as you go from krypton to potassium, the mass increases from one to the other, right? If you go from K to Kr, it increases for mass, but as you go from, slow down, Fox. As you go from krypton to potassium, the radius gets smaller because of the attractive forces. Okay, there's other words and other terminology. We're not going to get into that. That you get to do when you get to AP Chem. So the next thing we're going to talk about now is the atomic or the ionic radius. Okay, and that's when you talk about your charges. And we have to remember the difference between our cations and our anions. Okay, so now we talk about ionic radius. Okay, again, you're talking about atoms that have a charge. They either lost or gained electrons in the process. So this is where it gets a little tricky, and I'm going to try to explain it to you the best that I can. And again, it's much better if I show you visually. So remember, francium again is our marker element here. And believe it or not, for the most part, it's going to happen the same thing over here, but on the opposite end. And I'll explain that. And notice it does not include the noble gases, because noble gases will never ever lose or gain electrons when it's talking about ionization. Okay, or sorry, ionic radius. Ionic. So no gaining or losing of electrons. They are content. So if you look at my makeshift periodic table again, all right, we're looking at the same trend, doing the exact same thing, okay, and going down. So most importantly, we understand that as you go down, it increases and so forth. Okay, so really quickly, I showed you the easiest, which would be to show you sodium. Okay, so if I show you sodium, look at this example first. All right, if you're looking at sodium, easiest example to show is, notice how there's one electron in that outermost shell? There's just one. It's extremely unstable. This is why it's so reactive. It just wants to get rid of that electron. And if it gets rid of it, it looks like a noble gas. So guess what? Sodium is more than happy to lose that electron, and when it does, it becomes an ion. It loses an electron, becomes an ion, and now it is stable at 10 electrons, 8 electrons in its outermost shell. It is full, it is content, the octet is done, and it is neon. The whole point of what everybody on the periodic table is doing, trying to look like a noble gas. Yes, he's a poser, but he doesn't care because he's a noble gas now. All right, well, same concept, but when we go down to something like gaining an electron, okay, so in this case, we're going to talk about fluorine. Fluorine has 9 electrons. So if you show him, he's got his little 9 electrons. Look, he just needs one more. If he gets one more, he's going to have 10. So that's what he does. So in the first example, you lost an electron. And because you lose an electron, you lose that whole shell, which means you get smaller. So the ionic radius actually gets smaller as you lose those rings. So if you went potassium, of course you'd have an extra ring. So you'd have actually 4 rings around your around your potassium. Lose that, then you go to 3. Then you lose more and you go to 2 and so forth. So that's why as you go down, it gets bigger. Now when you're talking about the other side of the periodic table, here you are, here's fluorine, and if you gain an electron, you get bigger. So you technically get bigger because you're including that electron. Now I know you guys are going, wait a minute. Just a few minutes ago you told me that if you add more electrons, it actually has a greater pull toward the center. Remember, we're only talking about ionics. We're only talking about the ion, not of a stable neutral atom. So in this case, we're talking about fluorine with an extra electron that it's not supposed to have. So because fluorine's not supposed to have that extra electron, he's actually getting bigger. Super confusing, I get it, but just go with me. Okay, which means that's why as you go down on this side, the same thing is happening. If you go to neon, Now you go from, sorry, you go to chlorine, I apologize, because remember these guys don't play in this game. All right, so chlorine gets another one. Now not only does chlorine have another extra shell, he also has an extra electron than what he's supposed to have. So he gets bigger. And then bromine, same concept. You're getting another shell, so another one to get bigger. So your radius is getting bigger and it's getting heavier with electrons or larger due to electrons that you're not supposed to have. So hopefully that makes sense and that shows you the periodic trends. I'm going to do a real quick review here in a second for the last video that just shows reading a couple trends, and you should be good to go for tomorrow. Let me know if you have any questions.